So welcome to lesson 2 of the refresher course. So today we're going to solve some quadratics and we're going to talk about how these connect to the graphs and things like this. So, okay, so let's do quick warm-up. We're going to look at this quadratic here. And what we had yesterday was just this piece. Okay. But today we're taking that and we're putting it into an equation. And that changes things because that's going to allow us to do something called solving, which is going to allow us to basically say that x is equal to something. Okay. So the question that we have to look at is these are the possibilities. If we solve this, x could be equal to 2 and x could be equal to 3. Or x could be equal to -2 and x could be equal to -3, or x could be equal to 6 and x could be equal to -1, or none of the above. So just have a moment, maybe just have a think to yourself, just like kind of guess at one of these, like something that might work here. And now what we'll do is we'll go ahead and solve it. Okay, so I'm just going to go ahead and do exactly what I was doing yesterday, and I'm going to carry this equal 0 just down, just copying it down like this and so on as we go. So I have two numbers that multiply to give me x squared. That's this one here. My possibilities for 6 are 1 and 6, or 2 and 3. And I get a plus 6. So that tells me that it would have to be like a minus and a minus, or a plus and a plus. And I end up getting a -5. So if I've got 1 and 6, yeah, I can get 5 from 1 and 6, but they have to subtract from one another. And for so that would be two different signs. So then we wouldn't get a plus sign. So that leaves us with the 2 and the 3 having to be the answer. So I put a 2 here and a 3 here and a minus here and a minus here. Okay, so we would be done if we were just factorizing like we were doing yesterday. But we have this is now being put into an equation, so we can go further. What we have is, and remember, when I say brackets, basically anything inside of the brackets is just a number. It doesn't matter how complicated the thing looks. Once we put brackets around it, that makes it just a number. So we have something in brackets by something in brackets. In other words, a number multiplied by a number to give 0. Let's have a number like a multiplied by b to give 0. We've only got two possibilities. Either a is equal to 0 or b is equal to 0. That tells us that either the first thing, x minus 2 equals 0, or the second thing, x minus 3 is equal to 0. And you know what? If x minus 2 is equal to 0, then x is equal to 2, and x is equal to 3. The x minus 3 is equal to 0, then x is equal to 3. So this is my solution, and these are also called my roots, and I'll get into that in a second. So this was the correct answer. So this is going to happen a lot. X minus 2 is a factor. We're going to see x equals 2, x equals plus 2 is a root. Okay, so we're just going to have to get used to jumping from the factor straight to the root. Okay, so x is minus 2 is a factor, x equals 2 is going to be a root. Okay. Okay, so what do we how can we think about these expressions like, the roots? And to help us like understand what we mean by the roots, we can go ahead and we can graph something. So let's take this one that we just did, x squared minus 5x plus 6. And what I'm going to do is I'm going to write the following down. F of x is equal to x squared minus 5x plus 6. And then I'm going to do the painstaking work of doing, well, f of 0, f of 1, f of 2, f of 3, f of 4, and f of 5. Okay, so what do we mean by this? When we write down f of x is equal to this, what we're saying is that this thing, f, is like some sort of number machine. So the box makes it like some kind of machine. And we have input into the machine, That's going to be the x value. And then we have output from the machine, which will be the f of x value, or sometimes we might call it the y value. But essentially, we're going to have input and we're going to have output. So the input in this case, we're just going to work out what happens if we put a 0 into this, what happens if we put a 1, what happens if we put a 2, a 3, a 4, or a 5. Let's work it out. So this would mean put in 0. So 0 squared minus 5 times 0 plus 6. This is 6. 1 squared minus 5 times 1. Well, that's 1 minus 5 is minus 4 plus 6 is equal to 2. That's 2 squared minus, that's 4 minus 10 plus 6. That's equal to 0. Then we have 3 squared, which is 9, minus 15 plus 6. 9 plus 6 is 15. 15 minus 15 is 0. I'm just doing this fast just to get this point made. We put in a 4. 4 squared is 16 minus 20 plus 6. So that's 16 plus 6 is 22. Minus 20 is going to be 2, which is the same as this one. And then this will be 5 squared, 25. Minus 25 will be 0. Plus 6, we get 6 again. Okay, so what I'm going to do now is I'm going to take all this here and I'm going to write them down in the following way, where I'm going to put in the input and the output like this in brackets. So we're going to make a pair where the input and output, just to put them side by side, I could call this the x and the f of x, or I could call this the x and the y. Okay, and that's going to be a point, right? We'll see that now in a second. So let me just make the brackets and then put all those pairs in. So the inputs for each of these were 0, 1, 2, 3, 4, 5. And then the outputs were 6, 2, 0, 0, 2, 6. Now what we can do is I'm going to take all of the inputs and I'm going to put all of these inputs onto a number line. And then I'm going to take all the outputs and I'm going to put all these outputs onto another number line. But what I'm going to do with that number line, that second number line, is I'm going to actually put it this direction. So this will be for the outputs, and then this one will be for the inputs. And then we're going to be able to basically make a point, and then we'll go down, and this will be the input number, and this will be the output number. Okay? And that's what we're going to do on the next page, and that's what we call a graph. I know that you know this stuff, but the point about it is not to, I'm not giving you, this is kind of warm up stuff, but also like revisiting concepts that you sort of already know and you're already familiar with. Sometimes there's a lot of value just to sort of see it from a different kind of perspective, right? Rather than just sort of rote learning, you just got to get into this kind of thing of like, okay, we do this, but like we can kind of sort of take a step back and think like, you know, sort of like what's really going on here. So I'm going to make my XY axis thing here. Let me go and put down my tick labels. So let's say 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. And then we've got this is 0, and then we'll have like 1, 2, 3, 4, and 5. 2, 3, 4, and 5. Okay, and then, okay, so then what we're going to do then is we're going to take this first. So 0 was my input. So this is my input. Well, now we're going to call this the X one. We'll call this one. So this is the X number line. This is the Y number line. So then it's going to be 0 and 6 will be here. And then 1 and 2 will be here. And then 2 and 0 will be here. And then 3 and 0 will be here. And 4 and 2 will be here. And then 5 and 6 will be here. So these are all of our input output pairs. So our inputs are all going here and our outputs. So we take the 0 and 6 as we can see. Okay, so now what I'm going to do is I'm going to draw a line through all of these. And this is my graph of f of x. Okay, so I put in then, so I put in these numbers 0, 1, 2, 3, 4, and 5 as inputs. But if I had put all the numbers in between 0 and 1, then I would have gotten all of these. And if I had put all the numbers between 1 and 2, I would have gotten these. And all the numbers between 2 and 3, I would have gotten these, and so on. So what we're seeing here is on this page here, we had this way of representing the function, which was as an equation, as an algebraic expression. That's one way to show the function. Another way to draw the function is to draw it. Another way is to draw it. So this is another way to look at that same function. And then when we look at that same function, we can ask a kind of a question of like, basically, where does it cut the axis? So where does it cut the axis? And the place where it cuts the axis are here and here. In particular, x is equal to 2 and x is equal to 3 are the places where it cuts the axis, and that's what we're going to call the roots. Okay, so so the question was, when we solve one of the things algebraically, this example here, when we solved it algebraically, we got these two answers here, x is equal to 2 and x is equal to 3. But if we think about roots, what we're sort of implying by this is a graph of the function, a sort of a graphical, not an algebraic representation of the function, but a graphical representation of the function. And we can see this is what the graph of the function looks like. And then when we consider this, what we're doing is when we say f of x is equal to 0, we're basically saying, well, f of x, you see, f of x is the output. F of x is the output. F of x is these numbers. F of x corresponds to this axis here. So if we say that that is equal to 0, well, we're saying go down this line here until you hit the 0, until you're here. F of x equal to 0 is the x-axis. This is the x-axis. So this is f of x is equal to 0 here. So by saying f of x is equal to 0, what we're saying is, where does the function, which is this line, where does it cross the axis? That's what we're saying. And we find it's at these 2 points, here and here. And these things we call the roots. The only reason we call it the roots is sort of like the roots of the tree or something. This is sort of where it's in the ground or something. You can kind of, like, sometimes I think about like maybe the surface of the water, like where a curve just gets submerged and where it's sort of coming out of the water. So that's why you sort of think about the root of it or something, right? So that's what we mean by roots in this context. Okay, so now we have a bunch of examples which are similar to the examples that we had yesterday, but this time each of them will have this equal to 0 part. So how are we going to proceed? Well, what we're going to do is we're going to just factorize the left-hand side, and then we're going to keep this equal to 0 part, and then we're going to end up getting values for x and y that we can call the roots, right? We can say that it's solved. Okay, so if this is the case, then from yesterday we could see that this here is it's no common factor. It's not a trinomial. I see a minus sign. I see 2 squares. So this is the difference of 2 squares. I'm writing these implied signs as I go from line to line. X plus 3 is equal to 0, and then x is equal to 3, and x is equal to minus 3. Okay, so what does that work? Let me just go back again. So I have this number here, multiplied by this number here. So this one, x minus 3 is equal to 0, implies x is equal to 3. So that's the first possibility. So if these two things multiply to give me 0, then either the first one is equal to 0, so x minus 3 is equal to 0, or the second one, x plus 3 is equal to 0, which means that x is equal to minus 3. So these are the two values for x. And also, if we think about a graph of these things, well, we have a plus number in front of the x squared part. It's an x squared graph, right? So it's either going to be a U shape or an N shape. And because it's a plus number here, it's a U shape. And so we have a U-shaped graph, which have roots of minus 3 and plus 3. So we have something that looks like this. Okay. Okay, the next example. So this is a trinomial. So 2 sets of brackets then equals 0. So x and x, and then 3 and 4, and then plus and plus. So I either have x plus 3 is equal to 0, or x plus 4 is equal to 0. And so I have like x is equal to -3, or x is equal to -4. And then if we go to graph this, we see again, this is a quadratic. So it's a U shape or an N shape, but there's a plus here, so it's a U shape. So now we go ahead and we make a graph, and then I'm going to go to -4 and -3. And now I draw a U shape that goes through the both of them. So this is what it will look like as a graph, okay? Now, let's just think about this for a second, right? So what happens, let's think about this backwards. So we've been solving, like for example, these trinomials, we've been getting two roots, which have been these whole numbers, and then we've been using them to draw the graph of the function. So let's go backwards. Let's start from a graph and go back to finding roots. And then, once we find roots, then we could go back to, the factors and get back to the trinomial again. So we'll do this backwards. So let me take an XY axis. So we'll do something like this. And what I'm going to do is just like put on some numbers like 1, 2, 3, -1, -2, -3, -4, like 1, 2, like 3 and 4. I'm not going to bother doing any here. And now what I'm going to do is like draw a nice, where is it? I'm going to draw a nice parabola shape here. Let me draw in a different color. So we draw a nice parabola shape here. And let's have a look. Oh, sorry. Let me do that again. Sorry. So I'll draw a nice parabola shape. Okay, so then I'll sorry, just preparing this now. So if I take a parabola shape and I move it around, okay, and here it is, and you can see it's going through those perfectly through those ticks. So this means that this parabola shape is connected to a function that's got like -3, see there in that direction, and +2 so this is like, this is like -3 back here, and this is like +2 over here. Okay, so that would be like x is equal to -3, x is equal to +2. So that's x +3 as one factor, x -2 as another factor, and then we'd multiply like x +3 by x -2, and then we would get out like x squared plus 3x minus 2x, like -5. So -6. So that would be x squared plus x -6. And then we could say, see, that's how we would recover out the function from that. Okay. So this was all coming from like x, the graph going through these whole numbers. What would happen if this graph here, instead of going through whole numbers, actually went through, what if the graph went like not through whole numbers? You see, what if it missed those whole numbers, you see? And what if it went in between, like so? So in this case here, it would mean that the root maybe is like x is equal to -2.5 or something, and it's equal to x here is equal to +2.3. Like the point is that we're never going to take like a number like 5 and sort of like be able to break it into these decimal numbers, right? We'd guess, we wouldn't be able to guess those decimal numbers. So this method of try to split it out, like see x and x, two numbers that multiply to be -5. So it's either 1 and 5 or -1 and plus 5 or +1 and -5. Neither of those combinations are going to give you this 2 when we add them together, okay? So that's where we have to use something called the quadratic formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And what these a, b's, and c's are is they are the coefficients. So the coefficient will be like the number in front of the x squared, the number um, in front of the x, and the number in front of just a number. So this is 1 because there's a 1. We don't write it, but there's the coefficient, the number in front of x squared is 1. The number in front of x is -2. So that's -2. And then this number here is -5. Okay. So we sub them into our formula. So it's -2. So it's 2 plus or minus the square root of b squared, which is 4, -4 times 1 times -5. So this is all over 2. So this becomes 2 plus or minus the square root of 4 plus 20 all over 2. So this becomes 2 plus or minus the square root of 24 all over 2. And the square root of 4, what we'll do is we'll take the square root of 4 by the square root of 6 all over 2. And then we can't get the square root of 24, but we can get the square root of 4, which is 2 plus or minus 2 times the square root of 6 all over 2. The 2 cancels in, so it's 1 plus or minus the square root of 6. So this gives me an x equal to 1 plus the square root of 6 and an x equal to 1 minus the square root of 6. And the square root of 6 is like, it's not a rational number, so it's like it's a number that never repeats itself. Okay, so it's basically a number in between. It's like one of these in between numbers, right? That we can't write as a fraction. So we would never guess that we could multiply 1 plus the square root of 6 by 1 minus the square root of 6 to give us 5, right? So we wouldn't guess that. And so what we're saying is that if this method for factorizing the trinomial doesn't work, we have to resort to this formula. Now we do not want to use this formula unless we have to, okay? But as soon as we use it, then we could say like this could be like, for example, 1 plus 1 minus the square root of 6. It's not, but this here could be, 1 plus this one here could be 1 plus the square root of 6. Okay. Okay. Okay, so we'll take this example. So this happens to be one that is factorizable. Okay, so how do we do it? So we factorize x and x, 2 and 3, x and x, 2 and 3, and it's going to be a +2 and a +3. It's going to be equal to 0, so that gives us two possibilities. Either x plus 2 is equal to 0 or x plus 3 is equal to 0. So this is x is equal to -2. This is x is equal to -3. So these are now going to be our two roots. We're finished. We've solved. And just in case we were wondering, we could also like kind of, this is a quadratic. So when we make a graph of this quadratic, it's going to be either a U shape or an N shape. And the square here, the plus in front means that it's going to be a U shape. So what we do is we draw a U shape. We go to -3. We go to -2, and then we're going to draw a U shape that goes between these two. Okay, so we're going to try that again. So let's try that again. I break it into two sets of brackets equal to 0. X and x, that's my only choice for this first one. And then I need two numbers that multiply to give me 3 and -3, and that add to give me -2. So I can say I can have 1 and 3, so it can be -1 and +3, or -3 and plus. So why don't I try -1 and +3? So x times 3 will be 3x. -1 times x will be -x. So that will be +2x. And that's not what we want. So what we want is actually +1 and -3. So x plus 1, that will work, is equal to 0. So that gives me x is equal to minus 1. And then x plus minus 3 is equal to 0. So that'll give me x is equal to 3. Okay, so I'll just have it implies, implies, and implies, and implies. Okay. Now, we could have also used the quadratic formula. Like the quadratic formula will always work. Now, it doesn't make sense to actually use it in this case because we can actually factorize it. But why not like just demonstrate it working? Like demonstrate that it'll give us the same answers. So a is equal to 1 is the coefficient in front of the x squared is the a, and a is equal to 1. The coefficient in front of the x term is the b, and that's minus 2. And the coefficient in front of the just the number is minus 3. Okay, so x is equal to like minus 2 plus or minus the square root of b squared, which is 4. It's minus 2 squared, minus 4 times 1 times minus 3, all over 2. So that gives us x is equal to 2 plus or minus, and that'll be 4. And then minus 4 times minus 3 will be plus 12. So it's going to be 4 plus 12. It's going to be 16 all over 2. And so we have 2 plus or minus 4 all over 2. And then when we divide the 2 in, we'll have 1 plus or minus 2. So we'll have x is equal to 1 plus 2, which is equal to 3, or x is equal to 1 minus 2, which is equal to minus 1. So x equals 3, or x is equal to minus 1, the same answer. So the formula gives us the same answer, but we don't want to use the formula unless we have to because it's significantly longer. And this thing that I did, like what I did, I went from this line and I went to that line there. Now, I kind of lectured you yesterday about this, but imagine you're going up a set of stairs, right? If you do one step at a time, like you're going to be grand, right? You're not going to fall over. It's when you try to jump 2 steps or maybe even 3 steps, you know, you're probably going to be fine. But this is the chance, like if you're going to fall on your face, it's going to be when you try to do something like this. Now here, going from 4 minus 4 times minus 3 to saying, well, that's 4 times plus 12, 4 plus like 12, you know, to give me 16. That allowed me to skip a couple of steps. But it wasn't so much faster, and this is like really where you'll make a mistake with a minus sign, right? So you know what I mean? Like I would do this sort of advisedly, right? Like only if you're super confident, you've done this a million times, like, but you don't really save too much time. Like you might think in the exam you don't have a lot of time. You do have enough time, and you should be you have enough time to do everything that's on the exam, like in a kind of a careful way. Like they've already sort of tested it before the exam's gone out. They've sort of sat down and done the exam, and they've done it at a certain pace, and they've found that you have enough time to do every question kind of slowly, if that makes sense. So you know you don't need to skip these lines. That this is the place where you're likely to make errors. But nonetheless, we have shown that we can answer this question like either using the formula or not. Now in this next question here, oh yeah, we link it to a graph. I think we're going to have one. Yeah, there will be some questions where okay, so for this one here, we have to link it to a graph. So we're going to make a graph from this. So let's just take x squared minus 5x plus 6. We set that equal to 0. We factorize, and then we're going to say like x and x. We're going to say 2 and 3. We're going to say minus and minus. We're going to say x is equal to 2, x is equal to 3. This is a quadratic, so we have either a U shape or an N shape, but it's a plus here in front of the x squared, so it's a U shape. And we draw the graph, we go to 2, we go to 3, and this is the graph. So importantly, as I was saying, like this here is the function y. This is the function y. But this is also the function. So we have an algebraic way of representing this function, but we have also a graphical way of representing the function. And sometimes, like, you know, let's say we would want to use, if we want to get a precise answer, we want to use the algebraic representation of the function, like x is equal to 2 or 2.5 or 7 or whatever. What is y, right? If we want to get a precise answer. But if we want to understand kind of behavior, like general stuff, like does it go up, does it go down, where does it cross the axis? That's where the graph is going to be useful to us. Okay, so we have a mini quiz. So maybe just have a quick go, factorizing the examples and then getting the roots. So you want to get the roots, so you want to end up with x equals in each of the cases. And then in the third case, even though you don't have to, go ahead and try using the formula. And then we're just going to have a little quick go at what the intercepts are for the last one. Okay, so we'll go through these examples now. Um, for the first one, we'll do brackets and brackets. So we've got x and x. We've got two numbers to multiply to give me three and add. So that's a +1 and a +3. And this here gives me, well, x plus 1, x is equal to -1, x is equal to -3. So this is a graph. We've got a -1, we've got a -3. And so, okay, this one here, x and x, 4 and 4, and minus and plus equal to 0. So this is like we got a -4, we got a +4, and it looks like this. Using the formula, okay, A will be equal to 1, B will be equal to -2, C will be equal to -8. So let's go ahead and write down the formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that will be minus minus 2, 2 plus or minus the square root of b squared, which will be 4 minus 4 times 1 times -8 all over 2. This ends up being 2 plus or minus the square root of 4 minus 4 times -8 is going to be plus 32. So that's going to be 36 all over 2. And then we end up getting 2 plus or minus 6 over 2. So that's going to be 1 plus or minus 3. So that's going to be 4, or it's going to be -2. Right? So that'll be x is equal to 4 and x is equal to -2. And the last one, we're going to talk about the intercepts. And let's just think about this for a second. Now we're using a new term. So previously we were using roots. So roots specifically was when we were crossing the x-axis. So this function, it could be y is equal to x squared, this first one, plus 4x plus 3. That's a way to represent this function. And this function can be represented graphically like this. And if we talk about the roots, so I'm just going to get into terminology, the roots is specifically when y is equal to 0. Y is equal to 0 means here we are on the y-axis, go down the y-axis until you hit a 0. Here it is. The y is equal to 0 means the x-axis, okay? So in other words, where does the function cross the x-axis? At this value and at this value. So x is equal to -3 and x is equal to -1. So these are the roots, okay? But are they the intercepts? Are they the intercepts? Well, the intercepts are not only the intercepts with the x-axis, they're also the intercepts with the y-axis. So we also have to think about that one there too. So the intercepts is just a little, this is just terminology. It's just the names that we're using to describe things. So let's find all of the intercepts for y is equal to x squared minus 9. Okay, so y is equal to x squared. So we'll find first of all, x squared minus 9 is equal to 0. This is how we'll find the roots. So this is, it's going to be x minus 3 by x plus 3. And this is going to give us like x is equal to 3, or it's going to give us x is equal to -3. So when y is equal to 0, x is equal to 3 or -3. So we go ahead and graph this. We go to 3, we go to -3. And so when y is equal to 0, that's 0 for y. And so that's the x-axis. That's the first one. And we have this is a plus, so it's a U shape, so it goes like this. So we have the roots, which are the intercepts with the x-axis. Here they are. But we're missing an intercept, and that's the intercept with the y-axis, that one. Okay, what's the intercept with the y-axis? Well, that corresponds to when the y-axis corresponds to when x is equal to 0. So x is equal to 0. What value of y does that give? Well, y is equal to x squared minus 9. If x is equal to 0, if we put a 0 into that function, y is just simply equal to minus 9. So that's at minus 9. So you see, this is, let's write down the points. This is minus 3, 0. There should be, sorry, I made a mistake with that there, didn't I? Just, there we go. So this is minus 3 here. This is plus 3 here. So we have minus 3 and 0. We have 3 and 0. These are the intercepts with the x-axis, and the intercepts with the y-axis is 0 and minus 9. Okay. So we just need to know how to play around with these things, right? Like, like how to connect, like, stuff in the algebraic expression for giving like the function into like points on the diagram and so on. Okay. And to be able to switch between these things. This is a concept that's not just something we've learned off, it's something that we can play around with, like as if it was something that we could rotate in our minds and look at from different angles and stuff. Okay, brilliant. So, no, that's not what I want to do. So let's now take some exam questions as examples. Okay, so we have now got basically about 18 minutes left. And what I want to do in these final 18 minutes is I want to take the stuff that we were discussing today and I want to look at a few exam questions. Like, this is not like, this is a refresher course, right? So in my normal classes that I do, I'll go through only exam questions. I don't want to kind of like do that here because I don't want, it's more about get a warm up for getting back to school and stuff. But nonetheless, I think it's kind of like good to see how this, what we talked about today, this knowledge that you have now can get you points in an exam. Okay. And also to look at the exam and consider how, how we should be looking at the marking scheme and finding out like what gets us marks and what doesn't get us marks and so on. Okay. So we have to solve the following quadratic equation. We can go ahead and start breaking it into brackets and do this sort of stuff here, but we've been given a clue. 2 decimal places. Okay. So if we were answering this question in this way, right, we'd have to find 2 numbers that we'd have to have the 3x and the x, and the 3x would go here and the x would go here. And 2 numbers to 1 and 1, right, or 2 numbers that multiply to give us a 1, and we'd have to sub them in. But the 2 decimal places bit basically means that these numbers that we're choosing to go here would have to be decimal numbers. And like, we're never going to guess the decimal numbers. So this 2 decimal places, this is a signifier. This is telling us that we have to use the quadratic formula. They don't say use the quadratic formula. They say correct to 2 decimal places. Okay. So, no, let's just leave all that there. Okay, so let's rewrite the question again. So 3x squared minus 5x plus 1 is equal to 0. And we're going to use the quadratic formula. In order to know to use the quadratic formula, we need our a, we need our b, we need our c. We see that our a is equal to 3. We see our b is equal to minus 5. We see our c is equal to 1. And now we can write down that x is equal to like minus b, 5 plus or minus the square root of 5 squared, like 25, minus 4 times 3, which is a times 1, all over 3 times, all over 2 times a, which is 3. This is equal to like 5 plus or minus the square root of like 25, like minus 12 all over 6. This is going to be 5 plus or minus the square root of 13 over 6. This is going to be either x is equal to 5 plus the square root of 13 over 6, or x is equal to 5 like minus the square root of 13 over 6. So it's either one or the other. And I think I have my calculator over here. There's my calculator. So where's my calculator? So, all right. So what's 13 and the square root of 13 plus 5? What's that equal to? And now like divide that by like 6 and I get like 1.434. Let me just write, I'll just go ahead and write down 1.4342. I'm going to round it up. It was 425, so I'll just round it up. 1.44342. Now I'm going to say, what am I going to say? So let me clear all that. Let me take the square root of 13 again. This is for the second one. This time I'm going to subtract the 5. And I know it's the other way around, but then we're going to divide that by 6. And we get this equal to like 0.23 24. Now you might have noticed that I've carried too many decimal places, but my kind of advice is to when you're working things out and you're going to have lots of decimal places, carry about 4, and then when you get to the end of the question, look how many they've asked for. So we've solved this. We've gotten our answers for x. X is equal to 1.434 or x is equal to 0.23, but they said to 2 decimal places. So x is equal to 1.43 or x is equal to 0.23. Hopefully I've gotten that right. Okay, now the answers to the question's finished. And now let's have a look at the answers. So the answers are x is equal to 1.43 or x is equal to 0.23. So I've got the correct answers. And let's have a look at the marking scheme. So 0 marks, we don't write anything at all. 5 marks, we get right down to here. Now let's have a look at how to get the low partial grade or the high partial grade. Okay, so the low partial grade, the quadratic formula written. So that means if we have written that down, we get 2 marks out of 5. Now, 2 marks out of 5 might not seem that much, but 2 marks out of 5 is 0.4. It's 0.4. That's 40%. If you did that in every single question, you pass. So like passing is like super, super important, right? So like, do you know what I mean? Like that's good to know because we wrote that down in like a fraction of the time. Like this whole question was quite long. This maybe took us 5 minutes to do. That took like maybe 10 seconds. So in 10 seconds, we got 40% of the marks. And then to get the rest, 60% of the mark was to go forward. That's really good knowledge. That's why I say, if you feel that you can't get through the question, that's fine. No problem. If you can't do the question, that's fine. But don't get 0. Whatever you do, do not get 0. Get the low partial, because these things will add up. And like, who cares about perfection? You know, like that's not what we're really about here. What we're about here is about getting as many marks as we possibly can get from this thing. Okay. So that's that. Another way to do it would be to say, for example, to identify one of A, B, or C. So if we wrote down A is equal to 3, 40% of the marks. If we wrote down B is equal to -5, you don't have to even write down the 2 of them. That's enough for 40% of the marks. Okay. Now let's have a look at the high partial credit. So they say 2 steps fully correct. So what are the steps? Identifies A, B, and C. That's one step. Fully substitute the formula. So basically, if we were to fully substitute the formula and not do, now that would have to be correct. Then we would get the high partial credit. Or if we were to incorrectly substitute the formula, like maybe put in a minus sign or not work things out correctly, but nonetheless get right down to the end of the answer, then we're going to get like, so that might be, we haven't actually done the substitution correctly, but we worked something out, not 0.223 and 1.43. Doesn't matter. Like once our work was correct after the initial mistake in our substitution, then we would also get the high partial credit, which would be 3 marks out of 10. And then the final thing, this full credit minus 1 is when you lose marks for a mistake. If we did not round correctly, if we did this and we did not do this, then we would lose a mark. And sometimes just that losing a mark is just like, oh, why did I do that? Like I just had to read so when you finish a question, you just have to check back, like, because you could stop here and you'd be like, okay, I'm done. Am I done? I'm probably done. Let's just move on. You got to look back and you go, was that what I was asked to? Just reread it, give each answer correct to 2 decimal places. You'd be like, oh, okay, I have to write that there. Like I know I'm laboring this point. This might seem like totally obvious, but I have like, I have marked a lot of work from students, and like this is where people make mistakes. It's just in the day, do you know what I mean? It's just little things, little mistakes that accumulate, right, and end up costing you. Okay, so it's just a discipline. Okay, great. Okay, so let's have a look at another question. So it says that show x is equal to 4 is a solution of the following equation. Well, if x is equal to 4 is a solution of the following equation, like what does it mean? It means the following. It means that if we had like x squared minus 2x minus 8 is equal to 0, if this was our starting point and we went and factorized it, then we would get these factors, and one of the factors would be x minus 4. And then from that factor, x minus 4, we would find, a root of x is equal to 4, a solution of x is equal to 4. So let's just do it. X and x, two numbers that multiply to give me 8 are like 2 and 4, 2 and 4. And I want to get a minus, so I make this one a plus, I make this one a minus. Then I have x plus 2 is equal to 0, or x minus 4 is equal to 0. And this gives me an x is equal to 2, gives me an x is equal to minus 2, and this gives me an x is equal to 4. So implies, implies, and implies, okay? So that is one way to go about showing that x is equal to 4 is a solution, okay? But we got to think a little bit, we should do this the other way around, right? Because as I say, like, it's like if you understand something, you understand it from a bunch of different points of view. Like what they're sort of saying is nearly like, listen, start from here, start from there, and just go back and show that it works. So if it was to work, basically we could sub it in 4 squared minus 2 times 4 plus 8, and it would give you 0. So we're going to check this. This will be 16 minus 8. Like, sorry, I'll do that again. It would be, sorry, I didn't write it down properly. This is what happens when you're Russian. It's a minus 8. So that's 16 minus 8 minus 8. Is that equal to 0? That's like 16 minus 16 is equal to 0, like correct. So this is sort of like, this isn't an equal sign. This is more like an equal sign with a question mark. Like, is it equal to 0? Like, is it equal to 0? And it's like, yeah, it's equal to 0. It just took us 3 lines to get there. Incidentally, that would be true as well as if we took in minus 2. So minus 2 to be squared plus like minus 2 times minus 2, like minus 8. So that'll be 4 plus 4 minus 8 equal to 0, question mark, equal to 0, question mark. This is like 8 minus 8 is equal to 0. That's true. So the point is that, like, in a sense, if we start off with this thing here and work our way down to the solution, we find that one of the solutions is x is equal to 4. So that's a perfectly valid way to do this question. However, a quicker and more sort of laser focused way to do the question is to apply this method here, where we simply, sub in the value of 4, and after we sub in the value of 4, we find, yeah, it fits to the equation. It satisfies the equation. That's not true. If we stick in, like, let's stick in something else. Let's stick in like 1. So if we put 1 in there, we get 1 squared minus 2 times 1, like minus 8, like equal to 0. Is it equal to 0? That's 1 minus 2 minus 8. Is that equal to 0? This left-hand side here is actually minus 9. Minus 9 is not equal to 0. So that it doesn't work for almost every example. except for the two roots. So if we sub in these two in here, we'll get our zeros. Okay, we'll get the zero, but not for anything else. Okay, so it's I'm laboring this point is because it's worth knowing, like, obviously these questions that we're looking at here, like these are kind of like more like book questions that I went through. The exam questions will be like the book questions, but with a little kind of twist, essentially. Like essentially, like they'll kind of ask you the question from a different angle. And it's really testing like whether or not you just know how to do things in one way, or else if it's a living concept in your mind that you understand. That's what they're testing. So that's why they ask you in this more like obscure kind of way, right? It's fine once you just have the experience of just seeing it from the other point of view. It is the same question, but it just has this twist, as I said. Okay, so we'll just have a look, so just simply subbing in the value, seeing that it gives you zero is enough. That's all you have to do. There were other ways of doing it. I think that, no, there weren't. They showed this one way. So this was actually, for this one here, you could get 10 marks for it. And like, okay, doing everything correctly gives you 10, doing nothing at all gives you zero. So let's have a look at what the low partial credit, which is like 3 out of 10. Any partial substitution into the equation whatsoever. So if we just did like, even if we wrote down like something like 4 squared, like that's 3 out of 10. You know what I mean? So you may not know how to do this question, but even the inkling of knowing what direction to go in terms of solving will get you 3 out of 10. And if you're in a position to get 3 out of 10, get 3 out of 10. Do not get 0 out of 10. Like never do that. That's the like you would be amazed at how many marks you can accumulate from stuff that you feel that you have absolutely no idea how to do. You will accumulate lots of marks even from partial knowledge. Like that's so it students feel really reluctant to do that because they don't want to write down stuff. They feel like they're being judged because they are, right? You're being tested on the exam. But you know what I mean? Like you have to get into the mindset of getting every mark that you possibly can in that situation, and like not caring whether or not it looks scrappy or not. Okay, so that's just a kind of a something to get into your head. Okay, so f of 4, if we wrote down f of 4, that would be enough to get us like that mark. If we wrote the quadratic formula for some reason, what would that do for us? Yeah, like if we wrote the quadratic formula, then we could get out 2 and 4. I guess it's not really the right way to do it. If we attempted to factorize it, so if we did some like set of brackets and wrote like, if we did our set of brackets and we wrote like an x and an x, then we'd get, then we'd get like thing. Or even finding one of the factors like x minus 4, just writing it down. Well, that must be a factor. Like even saying like, oh, if x is equal to 4 is a solution, then x minus 4 is a factor. Like that's also enough to get that 3 marks out of 10. Okay. Now to get the 7 marks out of 10, it's the full substitution. So you have to have done all of this, basically. So have to do the full substitution. Or you would have had to do this full factorization. Or you would have had to do the quadratic formula with everything substituted. Okay. And those things like, so let's just do it. Let's just do it kind of for an example. Okay. If we were doing this approach and we did this, let's say we just did this, like x and x. We've attempted to do, the factorization approach. So this is like already 3 marks out of 10. If we now do this and this is now 7 marks out of 10. If we were over here and we just wrote that 4 squared or something, that would be 3 marks out of 10. If we wrote this, then it would be 7 marks out of 10. Okay. And that's where I sort of think like a lot of times the students, it's like, I don't know, sometimes, whatever, I see my nephew playing video games and like he has to do something and he has to be absolutely perfect in every single step. And if it fails, he has to do it again and again and again. So it's that kind of training for this absolute perfection. This is not about perfection. This is about trying to get as many questions right as you can. And if you can't get them right, you have to get these partial credits. So I can't stress it enough. Okay, so just time for one final example. Let me see if I can look at a different one. Okay, so let's just have a look at this. Yeah, we'll have a look at this one here because I just have one final minute. Here they're doing a kind of an awkward thing. They're saying like, what's f of, here's my function. Like, they're not asking us what f of 0, f of 1, if some whole number is. They're asking us like f of 0.67. Well, we're robots. We don't care. So we're just going to do, stick in everywhere we see x, stick in 0.67, and then we'll find out what that's equal to. So we'll come over here and we'll find that it's 4.3267, 4.3627. And then we'll be like, is this the correct answer? Should I be drawing a box around that? Let's look at the question. Correct the two decimal places. Okay, 4.36. Now that's the correct answer. And then it says find the value of x when f of x is equal to 4. So f of x is equal to 4. Okay. This tells us that 3x squared minus 6x plus 7 is equal to 4. Now I'm going to bring the 4 across. 3x squared minus 6x plus 7 minus 4 is equal to 0. And I've got 3x squared minus 6x plus 3 is equal to 0. Okay, so this is what always happens in maths, and I said this last time, we had to do a little bit of tidying up of the original expression before we could get something that's actually familiar that we can answer. And we can even go further because we see this 3 is in everything, so we can divide across by 3. We get x squared minus 2x plus 1 is equal to 0. And if we started with x squared minus 2x plus 1 is equal to 0, then we'd have, well, brackets and brackets, two numbers that multiply to give me 1 and add together to give me minus 2. Well, that's minus 1 and minus 1. So x minus 1, x minus 1, x minus 1. So this is x is equal to 1. So when f of x is equal to 4, x is equal to 1. Okay. Okay, so that's enough for today. So just a quick recap, or maybe just a quick look. Yeah, for that second one there, the low partial credit would be if we set that equal to 4. So if we just wrote down like either this line or this line, we would get 3 marks out of 10. If we were to use the quadratic formula and we wrote down the formula correctly, or if we had A, B, or C, so if we said A is equal to 3, that would also be 3 marks out of 10. And so on. The high partial credit would have to get down to here, the correct factors, or the formula fully substituted. Okay. And just as a quick recap of what we did today, so we were solving quadratics. So what we were doing was finding out, we were setting y is equal to 0. We had quadratic equations, we set them equal to 0, we factorize, and then we get out two roots. We use factorising. It's the fastest method when it's possible, but if you can't do that, then you use the formula, the quadratic formula, and the roots are where you intercept with the x-axis. Okay, so that's it for today. Same time tomorrow. Tomorrow, I'm going to go on with something else. Yeah, okay. So, yeah, thanks, and then I'll see you tomorrow.